Hello, everyone. Hello, Vinit sir. I hope you recently joined. So the people who have recently joined, let me point you in the right direction. So basically, these revision hackathons happen as in a cyclic manner. So basically, all the lectures that are covered by the primary faculty are going to be revised in the hackathons, right? So if at all you missed any of your previous sessions or you want to cover from the back, from the scratch, you can start from the beginning of the lectures, right? So we are here to help, and if you require anything else apart from that also, you can always reach out. So let me show from where you can find these particular details. Okay, so my screen is being shared. Great. So once you your teachable, you can see that this is how the your course will look like, and we have finished revising the concepts, the introduction, and we have covered 1.4. We've recently started the statistics, and within that we have completed the hypothesis testing, t-tests, and then the chi-square test in our previous session. So we are going to cover confidence intervals. So you can stay in and understand how this is happening, but I would recommend to go through the actual lectures from the beginning if you're trying to build the concepts from scratch, right? So this will be far more helpful than trying to directly parachute within a complex topic, right? Yeah, so yes, Vinit sir. Yeah, so all of those will be available last evenings, which is inner cycle, Vinit. Okay, so on track, struggling with success mindset part. Okay, can I have the schedule, please? Yes, so basically all the hackathons happen with a specific schedule, sir. So every day 4 o'clock in for AI.
Take this topic forward. So my request to all of you, please have open mind. This is not a fault finding session.
Okay, I think
We
somebody
are
has.
talking about a win-win approach because you are.
Okay, somebody's meeting is being streamed. Okay, sorry for that. Now, so as we, so Vinit sir, so what I was telling you here is, so the inner circle, you can go here. So the first way is to always, whenever you receive your email, in the email, you'll have the link to the Zoom session, and there will be a link to the restream video link also. You can watch it directly from there. So it will be there on the channel. It will be unlisted, but because you have the link, you'll be able to open it. Yes. So yes, sir. All of these Tejinder sir, all of these sessions will also be there in the email that you received when we were notifying about each and every session as well, right? So all of this will also be available in the inner circle along with the collab files, right? So you'll have access to the course, the inner circle Hall of Fame and all. So you have to go to the inner circle, and towards the end, you'll be able to find the hackathons. Okay, so I hope that answers the question. So you can even access, yes, Rahul sir, you can access it from the email as well. Great. So, okay. Yes, Vinit sir, I can completely understand. So that is the reason I would suggest you go through the beginning sessions. Let me share a resource with you because we have 2 to 3 people here who want to start from the beginning. I'm going to share with you this links to the streamers, right? So you can go here. I'm going to share with you a link to a playlist. Yeah. So this is the link to the first hackathon. I'm sharing it over the chat. right? Yeah. So you can see that in your teachable course from the beginning itself, you'll be able to find all the lectures. But if at all you want foundational introduction to Python, then this is the resource that will be helpful for you. Okay, so basically, maybe this Vinit sir, how this is working is like maybe by the time you've joined in the community, you might have already, the course, the hackathon sequencing, the cycle might have already started. So that should not be a problem. All the lectures, the recorded sessions are also there on your inner circle as well. Yes, thank you so much. Okay, great. So thanks everyone for patiently being there. So let me also share with you today's agenda. Great. Let me know if my screen is visible. Yeah. So we are going to cover the lecture, which is 2.3, the confidence intervals. In this particular session is relatively a smaller session. So I am going to, walk you through that. This is a very, compared to the t-test and chi-square test, this is more to work with the direct, variables and the formula, right? So the functions that are there within Python. Okay, so let me go ahead. Let me have my chat open. Great. So I'm also going to share the link to the collab file. So a few of the portions for better access, we will be covering it in our upcoming session also. Yes, so the link is here. Thank you so much, Tejendra sir. Yeah, so now if we start from the beginning, right? So what is the confidence interval, right? So let me share with you a few ways to understand this in a better fashion. Okay, I hope my screen share is visible. Great. So now, whenever, because we are working with numbers, means, and stats, most of the times people might ask, see, how confident you are. Basically, what is the, from what is the range of your confidence, right? So that is where the confidence interval comes into picture. So for example, a few of the examples. For example, most of the, we'll also know this for a fact. This is also proved by the central limit theorem that we have learned previously. So whenever you take sample means of a bigger population, right? Say, let's say we'll also be taking the body temperatures example. Whenever you are going to take the fraction of that bigger sample, the sample had like, let's say 220, and the whole population was 220 people's temperatures, and if we are taking a fraction like 10% of that particular observations, so you can see that the whole population's mean, the whole population mean will always be 95% of the chance is that it will be in this lower limit and this upper limit, right? So every population and its own, the mean of that will always be between a specific lower limit and an upper limit. And so whatever this range that is being covered here is the confidence interval, right? So for example, here in this example, if they say the confidence level of 68.26%, what they are meaning is there's like 68.26 chance that the mean will be within this particular range, right? So if you are talking about 95% of confidence level, this range will increase, right? So apart from the 5%, the 2.5% towards the ends, which are going to be the outliers, the whole range will be within that, right? So this is what we are going to understand in a deeper sense. So CI, the confidence interval, the formula for that is, X plus or minus T star. So we are going to understand that formula within our collab file only, right? So you have access to the collab file, and I would request everyone to have the collab file open, right? So that we can learn together and also practice. So let's understand the objectives for today's session. Now, we should be able to explain the purpose of confidence intervals and identify applications for their use, right? So we'll also explain the implications of central limit theorem in inferential statistics, right? So what was central limit theorem? In our previous sessions, we have seen that, let's go ahead and, revisit our central limit theorem. So when the large sample size, so the sample will be normally distributed, and the mean of the samples will approximately equal to the mean of the whole population, right? So what this meant was, whenever you are taking a larger number of samples, if you are going to take large amount of sample sets from the whole population, the samples will be normally distributed, and the mean of the samples will be approximately equal to the mean of the whole population. So the more means you take of the sample sizes, you will be closer to the mean of the whole population. So this is what we have learned in our previous sessions about the central limit theorem. And we'll also try to understand how the implications of that are there in inferential statistics. So we also understood, even Jay sir in the actual lecture tells us about this. We have understood inference is nothing but the insight that we are taking out based upon the data that we are generating, right? So now inferential statistics is where you're using stats for making the inference. Now, we should be able to demonstrate how to build a confidence interval around a sample estimate. And we'll also understand a little bit more about margin of error, and we'll also see that with the help of a graph. And the concept of statistical estimate, precision, and standard error also will be covered, right? So let us dive into this. So what are confidence intervals, right? So in the past two sessions, we discussed about the t-tests and the chi-square test, where we understood we used t-test for numerical data and chi-square test for understanding the relationship between two categorical variables, or the proportions of two categorical variables. Now, in those cases, when we rejected the null hypothesis for one independent sample test, one sample t-test, we say that we believe that the population mean is not equal to some reference value, right? So let me try to show that. So basically H naught here, the null hypothesis, whatever is there, we are going to reject. So whenever we reject a hypothesis, we are going to reject the H naught. And what we were doing is, we are saying that the population mean is not equal to some reference value. Reference value is, in the Coke example, it was the 34 ounce, or in different examples we had a different reference value, right? So now let's say 2.1 was our one sample t-test, right? 0.2 was great. So now if you look at the H naught, and let's see. Yeah. So we reject, whenever we reject the H naught, the null hypothesis, we reject that, whatever the hypothesis was there, right? So in one of our examples, let's go ahead and see that. So now here, one of the hypotheses here was this was the brain size example. The mean of the younger audience and the mean of the older audience is equal was the null hypothesis. And similarly, H naught for the body temperature example, which said the mean is equal to 98.6, and the alternative hypothesis was the mean of all the body temperatures is not 98.6, or the opposite of H naught. Right. Similarly, when we are coming here, when we reject the null hypothesis, we say that we believe the population mean is not equal to some reference value. So this reference value is specific to that particular example. Here it was the reference value was 98.6. In Coke example, it was 34 milligram of caffeine in 12 ounce of Coke drink. So similarly, that is how this went, right? So now this is the confidence interval, right? So now the purpose of a confidence interval for a one sample t-test is to allow us to estimate a population parameter, right? So which will help us to be sure, right? So when we are saying that we are 95% sure that the mean will be between this particular range, right? So a common life example would be like this, right? So how long will it take for the brownies to bake, right? So then we say about 35 to 40 minutes. And how many cookies should I bake for a bake sale? Probably around 2 to 3 dozen. So these are where we are, saying with one, confidence that we have, right? That is the range that we have. Now, if somebody says, I have, something important coming up, tell me with 100% surety that how long will the brownies will, take to bake. Then you say, if you want to be 100% sure, take 60 minutes. Within 60 minutes, you are definitely going to, see that the brownies will be baked. So what happened here is when the statement that you said, like within 60 minutes will be ready, because you know that within 35 to 45 minutes, 95% of the times it is going to be true. But if at all, there could be some, this particular sample of brownies that you're baking, if it is taking more time, it might take 50 minutes, but you can be more sure. Yeah, I'm just giving you, if we are not going to put Suju ma'am says will burn in 60 minutes. What I mean is you can give a person a range of time. That's a good one. So you can give a person a range of time telling that, okay, this is the time you can plan for your important thing. Thank you so much, ma'am. Right. So when we'll also see that when somebody asks to be 100% sure, we are going to give a bigger confidence interval, right? So if somebody asks me also that, how should I, tell me with 100% surety, I would say, okay, first I'd say it will take this much time, and then say be sure, then I'd say the larger time frame, right? So to be sure. Okay, so this is how the confidence interval work in our daily life. Let's try to understand that. So like in our previous sessions also, we have seen chi-square test and, our one sample t-test and two sample t-test. We'll understand the concept, but there will also be a simple formula that Python modules will always have. But let's try to understand more of it. So the anatomy of confidence interval. So what is the formula? We have seen confidence interval, the Ci equal to x bar plus or minus t star. So this is not like a multiplication here. We are saying t star into s by underscore n. Yes, Sivakumar, we have not gone through any of the video lectures, just finished orientation for me. Yeah, so Sivakumar sir, I would request you to go through the beginning of the lecture from the beginning, right? So I would reach out. You can always reach out and let us know where you need help. So this would be definitely a little parachuting for you. So I would request you to go through the beginning of the lectures. Yes, sir. I've shared. Great. So Vineet sir, I think I will also share the reference with you. If there's anything, you can always reach out. Thank you so much. Great. Yeah. So when we make a confidence interval for a population mean, we will use the information from our sample, right? And the mathematical properties of the t distribution, right? So the t distribution, if you remember, the curve, this is what we were talking. The curve, the t distribution curve is something that will come handy while we're trying to understand the confidence intervals, right? So the formula is going to be this. Let's try to understand what each of the variable is saying. So where x bar is the sample mean, so S is the sample standard deviation, S here is the sample standard deviation, and N is the sample size. So N is always easy. So the number of observations. Sample standard deviation, we have a formula in Python for that. And sample mean is also something that we can generate, right? So note that S by underscore N is the standard error. So there is a name for S by underscore N. So the variable, if you have, if someone asks you to calculate the standard error, we always do sample standard deviation by underscore sample size. Right, so this is how we also calculate the standard error, which is, so what is standard error? So which is an estimate of the true standard deviation of the sample mean, right? So this is about the formula. So the another name for the quantity, so basically, like now we know that S by underscore N is standard error. So there's also a name for the whole T star into S by underscore N. So that is called the margin of error. So we'll also calculate the margin of error as well. So how much margin do we have for error is also something we'll estimate. So you can understand this in a different way now. The confidence interval equal to x bar sample mean plus or minus the whole thing is margin of error, right? So sample mean plus margin of error, sample mean minus margin of error, you're going to get your confidence intervals, right? So margin of error is nothing but T star into S by N. So which is, you can say margin of error is T star into standard deviation, right? Oh, so standard error, right? So let me, try to write it here. So the confidence interval equal to sample mean plus margin of yes, we request the people who have joined just now to mute. Yeah, the margin of error. And now we know, so sample mean plus or minus, right? So I'm just giving this for, little better understanding. Okay, sorry. Now, what is margin of error? We've understood margin of error is equal to T star into S small s by, square root of N, right? So this is what we have done here. So now the margin of error is T star into S by square root of N. This is there. And the other name for this is standard error, right? So we also understood that here, right? So the standard error is S by underscore N. So you can also have margin of error is equal to T star into standard error. Great. So now we'll understand more about this, right? So this is just an example. So if you remember this sample mean plus or minus margin of error, you will have the confidence interval, right? So the confidence interval is always going to be this, right? So between 35 to 45 minutes, right? So you have a mean and you say, so for example, what is the mean of 35? is 45 by 2. So it's going to be 80. 80 by 2 is 40, right? So now when you say 35 to 40 minutes, what you're saying is your sample mean was 40. It might take plus or minus 5 minutes. So that was your confidence interval, right? So I hope if the confidence interval concept is clear. So if confidence interval is clear, type C in the chat box. Yes, Rajamurthy sir. So you can always, Rajamurthy sir says, in the process of completing the orientation modules, yes, sir, you can definitely go forward and complete the modules and then join the hackathons, or you can start from the beginning. So I've shared the details also. If there's anything, you can always reach out, sir. Yes, thank you so much. Thank you, Suju ma'am. Thank you, Rahul. Thank you, Prashant, for letting me know that you understood the, the range, the confidence intervals range, right? Okay, thank you, Vinita ma'am. Now you understood that. Now let's go ahead and try to calculate. Yeah, some of the calculations are very easy, like sample mean. We'll do that with our standard way of learning by example, right? So we are going to take a data set, which we have already worked with, the body temperature data set, right? So what is this body temperature data set? It's going to people who are joining just today and trying to understand what is happening. So there is a CSV file that is online uploaded, and we are trying to import that for use within our program, right? So that is what we are doing. So we are taking that URL and giving it to a Python's function. You'll learn more in, when you're starting from the beginning, right? So we are going to, take a data frame, say df, and we are going to read that CSV within this, right? So if you want to see the contents of it, we are going to say data frame.head. Yes, Tejendra sir. So do not worry. So this is how you can reach out, sir. Thank you so much. Right. So I'll be sharing with you the reference from where you should start, and I'll be pointing you in the direction so that you will cover from the basics. Thank you so much, sir. Yeah. So now we know that this particular body temperature, these are the IDs and these are the temperatures. So Vinita ma'am asked, if it is an Excel file, how can I convert it into CSV file? Okay, ma'am. So maybe this could also help, everyone. So whenever you have a CSV file, so basically you can always go to Google Sheets, because you do not need any particular thing. So I'm going to download this file. Okay, so this particular file, let me see if I'm able to do that. Okay, so okay, I got it. Okay, so I'm going to the data sets. For example, our data set was called any data set. Okay, so just to see if the body temperature is here. Yeah, so I'm going to download this data set. Okay, let's assume that you have the CSV file with you. You're going to download it. Okay, so let me go ahead and download this. Okay, so I guess downloading is okay. I'll try to download it from here itself within datasets. Yeah, so I think it will download the whole zip first, and from there I'm going to import it here, right? So there's also a way to download an individual file, but yeah, maybe yeah here. Okay, so no worries. I'll assume that you'll have that in your file. So I'm going to open import your CSV, and I'm going to say datasets. and I'm going to use any CSV. I'm going to use the body temperature CSV, right? And I'm going to either insert new sheets, or you can say append to current sheet, whatever works, you can say. So you'll have that CSV file here, right? So now you can always go ahead, file, download this as an Excel, right? So this is how you can download this in Excel. You can do the same thing in your own Excel, MS Excel also. You can open the CSV and download it as an Excel, save as Excel. But I would also request you to go through another way. Instead of always trying to read CSV, there's another way which we have covered previously, where you can read an Excel, right? So read Excel file in Python. So if you do not want to go through conversion and all of these, there is a function where you can read the Excel file, and you'll be able to work with that, right? So I hope this was helpful, ma'am. Great. Thank you so much. So yeah, so thanks for that, and it also helps everyone. Now we have this data set, and within this data set, what we are going to do whenever we are working with means, we are going to work with a sample set. Now what we are doing here, we are going to create another data frame and calling it sample, right? So we're calling it subset, and we are doing dot sample n equal to 20, which means copy 20 records or observations from the data frame and put it in the subset, right? So if you remember, previously we used the formula fraction or equal to 0.1, where 10% came directly, or you can always use number to specify how many observations you want in that. Now we have a new data set which has just 20 observations in that, right? So now we are going to work with that and see more about the confidence intervals, right? So the more accurate you want to be, the more likely you want to be able to capture the true population mean in your CI, the less precise. So basically, yeah, so to explain this, I think this also comes as we go forward. What this means is, for example, if someone says, how long will it take? So you said 35 to 45 minutes. You are more sure, you wanted to be like, let's say 95% sure. So you gave an accurate confidence interval, but somebody says you want to be more accurate, then your confidence interval becomes less precise, because you said, like, it will take 60 minutes, or let's say it will take anything between 30 to 60 minutes, right? So you have increased, your mean was 40, you have earlier it was plus or minus 5. Now what you have done is, just because you wanted to be more accurate, you went ahead and made it 30 to 60, right? So you increased, so the precision decreased, right? So this is what we are talking about here. Okay, great. So now the two variables in the data set are participant ID and body temperature, measured in Fahrenheit. We can use the mean and the standard deviation, the row counting functions, to calculate each of the variables, right? So let us go ahead and do that. Okay, so now we have the data frame here. If you use the dot describe function, it is going to give you count, it is going to give you mean, the standard deviation, right? So you got your three important variables that are going to be used. You got n, the mean, and the standard deviation, right? So the describe function now makes more sense when you're trying to work with the confidence intervals. Yeah, so Vinita ma'am, so the accuracy and precision, we'll also cover that as we go forward. So basically, when you want to be, when you want to be more sure, if you want to be the precision here, you say you want to be 95% sure, right? So let me go ahead and show this interval, right? So in this example, ignore the lines or numbers. Like, for example, 95%, you are sure that your mean would come between the lower limit and this upper limit, right? 95% of 95% you are sure, right? 95% of the times, the body temperatures are going to be between 98.2 to 98.4. Like, let's just say I'm giving you an example. But if at all you want to be 100% sure, so you are increasing your chance whenever you want to be more accurate, you say anything starting from 96 to you will give the larger sign. You're going to say 108. I'm just giving you an example, right? So you are going to give the minimum value to the maximum value, right? So let me give you an example here in the dot describe function only. So the minimum value in this data set is 96.7, the body temperature. The max is 99.6. So if somebody asks you, can you give me, when you are taking mean of any sample data set, if you are willing to be 100% sure, what is the confidence interval from where to start and where to end? So you will say it will definitely be between 96.7 to 99.6, because that is the minimum and maximum that you can have on your interval, right? But when you say that, your precision, right, your accuracy dropped, right? So you were more sure when you said it is between 98.02 to 98.4, you are more accurate. But whenever you wanted to increase your confidence interval, whenever you want to be more sure, 100% sure, not 95% sure, you want to be 100% sure, then what happened is your precision dropped. I hope that makes it clear, Vinita ma'am. Great, thank you so much, ma'am. So now the describe has given you your three things that you will be using in your formula for confidence interval. Let's go ahead and manually calculate also. We have the dot mean function to give mean, right? So we have got the mean, but we have used, because we are going to use it in the function, we need variables, right? So confidence interval will have its own function. You need to pass parameters into that so that you will get your confidence interval, right? So the minimum and the Rajamurthy sir, thank you so much, clear so far, right? So I really appreciate you, Rajamurthy sir, because you're still trying to continue understand as we go forward, right? So do not worry. This particular collab file does not require you to install anything. You can definitely go ahead and run it. But if you want to be more sure about each of the concepts, you can definitely start and parallelly, start from the beginning. Thank you so much for that. Right. So now mean body temperature, we are saving this value that we got mean by using the dot mean on the data frame. And then we have saved it. So now we know that mean underscore body underscore temperature is having the value 98.16. Yes. So now let us also go calculate the standard deviation, right? So the standard deviation here we got is 0.52. If you want to calculate it by self, you're going to use the dot std formula and save that in the standard body temperature, right? So n is definitely easy, but we need to save it in a variable. So we are going to say length of the data frame. So when you say length of the data frame, it will give you the total number of values in that data frame and save it, right? So now what all we got? We've got, if we come to our formula, yes, we have got n, we have got the standard deviation, and we have also got the sample mean, right? So, okay, let me just plug in. Just give me a second. Sorry for that. Yeah, so now we have a sample mean, we have S, and we have N, right? Only thing that we do not have is T star. And what was T star? T star is basically, okay, so let me point you there. Okay. So we're going to calculate T star also. Let me show you T in confidence interval. Okay. So, so basically the T. So when you want to find the T value, you are going to Okay, so this is directly giving you the critical interval, the confidence interval formula. So let's go ahead and also calculate that, right? So how do you calculate is also easy. There's a formula for that. Let me go ahead and share with you. Great. So now T star, okay, I got it. T star is the number that tells us how many standard errors to add and subtract from the sample mean in the CI formula. So this is like number that we'll be generating, which will give us how many standard errors, right? So how, like, basically, if you can say, like, you can just have two errors in that particular mean, right? So it's, you can tell this is T star is going to give you that particular number, right? So we're also going to calculate that, right? Okay, so now we have all of these. Now we have also got the standard deviation. Now, if at all you want to calculate the standard error, if you remember, how do we do that? The standard deviation by square root of n, right? So we have got the standard error also. But there is also a simple formula, like how we have .std for standard deviation. For if you want to calculate the standard error, you can always go ahead and use SEM, right? And now you have SC in this, the standard error also, right? So now we have everything, and we have also put in all of these, right? 0.53, the N223, and the sample mean also, right? So the mean also we have got. So we have also plugged in all the values in the mean, and T star is something that we have not yet calculated. So how do we calculate T star is also, there's also a formula. Even Jay sir in his lecture explained, this is mathematically, if you want to calculate how many standard errors to add or subtract from the sample mean, that is mathematically little intensive, but because we have our formulas within Python, it becomes easier for us to calculate T, right? So not worry too much about how we calculate the T star. So we'll just go ahead and use this particular formula to generate T here, right? So we're going to use the SciPy modules, and out of that stats, and we are going to import T, right? So we know that the data frame, the body temperature is equal to N body temperature. So recall N is 223. We have got that. And now we are going to calculate T star. So how do we do that? There is this function t.ppf, right? Let me hover on this so that I can, show you the pop-up, right? So which is called the percent point function, right? So you can use the percent point function and give the parameters to that to calculate T star, right? So even you can always go ahead and ppf in Python percent point function. So there is a little more assessment. You can go ahead and understand more about it directly on the the SciPy website, right? So you can understand from there itself. It will give you a particular value that is required for our function, right? So now we are going to use the percent point function to generate T star. So T star. So how we calculated standard error, which were easy to calculate, right? So standard error was standard deviation by underscore n. So similarly, there is a mathematical formula to generate T star, but we are going to directly use the function .ppf and given the parameters 0.09. So now 0.09, what is 0.09 is the confidence, how much, to what extent you want to give, right? So we are going to give the lower tail possibility. So let me go ahead and show you that. So we want to be 99% sure and give the T star for that, right? So that is what we are going to do here. We are going to do 0.99. You can also give 0.95 also based upon the problem that we are solving. Whatever is being asked, we can go ahead and do that. And then we are going to give the n, right, which is data frame, which is 223, right? So n, then we've also got the T star. So the value of T star here is 2.34, right? Yeah, so Shiva sir asked, this revision is particular module or right from beginning to which module? So Shiva sir, if you this particular module is a revision of 2.3 confidence intervals, right? So this is where we are. Yeah, so we are going to, every revision hackathon is going to cover one specific topic from the module, right? So we're not going to revise all of it. Definitely, that's actually a good idea, but that will be a bigger session, right? Where we want to cover from the beginning. Yes, I guess this would be our fifth hackathon. So you can definitely go ahead and calculate. So introduction to Python program was 1, 2, 3, 4, 5. Then we did 6th, 7th, and this is roughly 7th or 8th. Yes, I will be sharing the links with you, sir, Vinit sir and Shiva sir. Okay. If at all, do not worry, what you can just go ahead, like for example, if you're starting here, you can just go ahead and continue with these lectures, because this is a revision of the actual lecture, right? So you do not have to worry anything. So you can go ahead and start from here, understand. So there are 3 lectures being covered for introduction to Python, and then you go into the exploratory data analysis, then you go through the lecture. So because this is going to be like revision of the same, so it should not be a problem. Yeah, thank you so much, Shiva sir. Okay, that's a good suggestion. Thank you so much, Shiva sir. Right. So how do we do that when we are sending the mail? You can see that on the thumbnail, that image that you find, there is a small title that comes, but I'll make it more explicit and share it. Thank you so much. Okay, so because of the .ppf function, we got the Tstar also. Okay, now we have everything that is needed for us to calculate the confidence interval, right? So we are ready. So we're going to do it. Yeah. So Abhay sir, if you have a question, you can go ahead and put it on chat or maybe ask us. Okay. Yeah. So you've raised your hand. Thank you so much. So while you type in, we're waiting. So now we have everything. Now what we have calculated. Now, if you remember, the formula we have written out here. What is margin of error? T star into standard error. Okay, let's go ahead and calculate our margin of error. Okay, so that's what we're doing here, right? Okay, so the margin of error is the thing that we are calculating here. For our body temperature example, a confidence interval left off in the body temperature example, right? Because a confidence interval of CI, basically it is CI equal to sample mean plus or minus T star into the standard error 0.35, right? So we have got it. Now, which gives us the equation. We know that from the CLT that T star should be somewhere around 2 for a 95% confidence interval, right? So here we have calculated that. And further using Python, we know that T star for a 95% confidence interval for a body temperature data is 1.97. Okay, so let me go ahead and see if that is what is happening. Okay, so for a data set, quick check, this is very close to 2, right? Yeah, so what in our actual lecture was given as 1.97, we are getting 1.965, right? So I'm just not sure what the formula is generally, right? So what it is giving is how many errors you can have. Okay, so basically how many errors you can have is what you call, you cannot have 2.3 errors, you roughly have 2 errors, right? So that is the reason it has been mentioned as 2, right? So you cannot have how many errors you want. T star is how many errors you can have, right? So you cannot have 1.6 errors. So we are saying it is very close to 2, right? So that is what we have calculated here. And now because we have all these details, we want to calculate, we have T star into our standard error, so which is the margin of error. Now let us calculate the lower central confidence limit, right? So lower confidence limit. So which is like, for example, your mean was 40 minutes, minus 5 was 35, plus 5 was 40. Similarly, your lower confidence limit is whatever your mean body temperature is, minus T star in the margin of error, right? The margin of error is T star into the standard error. So now you've got 98.08, right? After all these calculations, now you got 95% of the chance that the temperature, the lower temperature of the whole population would be 98.08, right? So let us see the upper limit, which would be plus, right? So we are going to do plus of this, and you can see that the okay, so what we have done is we have just did an approximation here. When you said T star, the actual value of T star was taken. So what was the value? Which was 2.34, and here we have approximated it to 2, and then we have got the lower bound as 98.09, and the upper bound is also 98.24, right? So you can say the confidence interval is 98.09 to 98.24. So in conclusion, we are 95% confident that the population mean of a healthy human body temperature is between 98.09 and 98.25, right? Roughly approximating. Right. So if you have understood what we have done here and how we have got our lower limit and upper limit and eventually got our confidence interval, if you understood this, type C in the chat box as you're clear with the concept here. So in today's revision hackathon, what we tried assessing is how do we tell that, like, if at all we are 95% sure, what is your lower limit and higher upper limit, right? Okay, thank you so much, Suju ma'am. Right, so that is what we have understood. This we have done manually. Now let us see that is there an easier way? Yes, definitely there is. So there is a formula which says dot interval, and where you're going to pass the parameters, which is the standard error, the mean body temperature, the n value, and the range that you want. So basically we want a 95% confidence interval. So if at all you want that, you can say 0.95. If you want 99% confidence interval, you can say 0.99. Yes, Rajamuthu says the concept is clear, but I would like to do it myself. Yes, so the collab file is for that. You can go ahead and practice. So thank you so much. I really appreciate it. Now, what happened when we just use the simple formula? You got the lower limit as an output and the upper limit, right? So this makes our lives easy. Whenever somebody asks you for a confidence interval, you need not have to do all of this, but it is important to understand the logic behind it, right? So the dot interval is going to give you the confidence interval. So you can always say, whenever you're doing your stats, you can say, I'm 95% sure that the human body temperature in our example will be between 98.09 and 98.23, right? So this is what we can do in a simple way. But if we want to be X% confident? Like if you want to say, I want to be 90% sure, right? Not 95%, right? So now here, Vinita ma'am, your question also will come. Like, for example, if we are decreasing our accuracy to 90%, right? So now from 95 and rest everything remains same. Now you can see that your confidence interval increase, so 98.10 to 98.22, right? So that the confidence interval changes. So that is how you can say, if at all you want to be 60% sure, you can also go ahead and do a calculation of that, right? So it keeps on coming in that particular graph. If you want to go and graph it, you can also go ahead and graph it. We have seen how to graph, right? So now let us see, for the same example, how do we graph it. So do not go into the details of the whole of it. I'll just give you an example of how are we plotting. We have done all of this in the previous hackathons. So people who are just trying to understand here, you can just watch our previous sessions and you'll be able to understand. So we are using Seaborn as a module to plot. And here we are going to take a subset, which is n equal to 10, right? So we are going to work only with this particular subset. Now in that we are calculating mean, our standard error. We are calculating the length, the data frames length -1. We are going to take the confidence interval to be 95%, right? So that is also there. So now if at all we want to get the lower and upper limit, you're going to use the formula. So we're not doing the whole steps. We're going to say we're going to use the formula t dot interval and pass in all these values like the confidence interval, the sample, the data frame values, mean, and the sample standard error. And then you are going to get lower and upper CI, right? So this is for 95%. Let us, I'm going to comment the 90% and 99% to make it clear, right? So we're going to plot it only for 95%. Now, what we are doing here is we are going to do a dist plot. So what a dist plot does is it gives you a bar graph along with a your t curve also, right? So I'm going to comment here also all the plots that we are not trying to visualize right now. We're going to just only check the 95%. So what we are doing, we are going to use AXV line. So what this does is it is going to put a line, a vertical line on the graph, right? So we are going to plot the sample means line here, and it will be in black, and the upper limit will be in gray, and the lower limit will also be in gray, right? So let's go ahead and try to plot this particular graph, right? So I'm going to run this. Let's see if there's no error coming in here, because I commented a few sample mean. Okay, so we see that here. So let me just check body temperature. Is it not spelled properly? Let me just check. Yeah, so if you identify this, there any issue, just let me also know. Body underscore temp seems fine because it is getting evaluated here. Okay, so this would be our we are just towards n. So let me just undo and see if that is the error or there's something else. Okay, I think I have not run something that is above. Okay, sorry. Okay. Did I miss? Yeah.
Somewhere you have missed the body temperature variable.
Yeah, I think I have understood. I might have missed it somewhere. Okay, so let me just see if I can calculate it right away here. Okay, so what I'm going to do is, yeah, so I think.
Try to assign value for that.
Yeah, that's what I was going to do, right? So what was the mean that we got? The mean that we got is, yeah, 98.17. I'm going to give it the value with mean. Okay. So that should work. Okay, so it's everywhere. I think, okay, so I think Vinita asked the right question. Does the subset have the column body underscore temperature, right? I think that's something I should look at. Okay. Subset dot head. Okay, so that is the error. Thank you so much, Vinita. Okay, so this is for a different example, I guess. Okay, so let me go ahead and change my data frame, right? So what is the data frame? Thank you so much, Vinita, for that. Okay, so we had our data for it, which was DF, right? So it was not subset. Okay, so I'm going to, let me just see if this works. And wherever it is subset. Okay, so I'm going to check and run check this. And not this as well. Okay, so basically you get the idea, but yeah, I think somewhere there is a missed link where the data frame is updated. So because I don't see the body underscore temperature in this data set as well. Was it in subset? Yeah. Okay, that is strange. The statements that have run right now are not running, meaning there is some change that has happened. Okay, so I hope this was clear. Okay, let me just try to run this in my actual collab file that is put up here. That would have happened somewhere. Execute from the beginning, Vinita. It's always something that you can always do, right? Go ahead and execute from beginning. So I'm going to, also run it. Okay. I hope we are okay. It worked, right? So let me, please do not worry. People who have, just we kind of stuck here because there is some change in the data frame that happened. Run it. It's properly running. So right now. Yeah, so I'll be able to, yes, Vinita, now I'll be able to try with subset also. So now what I'm going to do, okay. Now instead of data frame, let me just go ahead and put it back to subset. These smaller changes that we have made here. Let me run it again. Yeah, so it is running. Let me go ahead and I'm not going to hide the values that we have calculated, but I'm going to hide the lines for a better plot. Thanks everyone for being patiently there. Yeah, so now if you see the sample data set that we have generated here, we want to see this particular thing. Now our sample mean is in the color. The plot of our sample mean is in black. So this is going to be our sample mean, and the confidence value that we have given, the plus or minus, is the gray value. So this is with confidence 95%, right? So now if at all you start plotting with confidence of 90%, so there'll be two more lines that get added here. Yes, so you can see that there are two more lines that got added when you are reducing the confidence. You want to be just 90% sure. You want to be 10% sure. You want to be like whenever you are reducing, the lines are also going to reduce in that particular. Your confidence interval is also going to change, right? So this explains that. Yeah, so I'd also see where that error might have happened, maybe somewhere in the formula here. But when you're running it properly, like from the beginning, it is not causing any errors. Thanks for that tip, Vinita. Okay, great. So I hope apart from the final glitch that we had, which had nothing to do with the concept, and it actually run flawlessly when we run everything. Apart from that, if there's anything, you can go ahead and ask. And if rest of it, if the concept of confidence intervals is clear, type C in the chat box. Yes, thank you so much. Thanks, Rahul. Thanks, Prashant. So people who are watching us on our social channels, you can put it on your comment section. Yeah, thank you. Yes, Rajamurthy sir. Yeah, so you can ignore the issues. You can run the same on your collab file also. The issue that we have run is the data frame that we are operating here. To explain what happened is, whenever we tried running it, it could not find this the body underscore temperature column in that particular data frame. And when we tried to see what is in that data frame, we also could not actually find. But when we ran, when you can go here in runtime and say run all, it will start running from the beginning, right? So there it automatically got sorted. Yeah, thank you so much for that. Thank you so much, Sujima. I would also ask you to go ahead and practice so it becomes easier. So whenever you want to just calculate the interval, you can just use dot interval to get your lower and upper confidence limits. Okay, thank you so much, everyone. Thanks, Vineet. Thanks, Abhay sir. Thanks, Anita ma'am. Thanks, Rajamurthy. Thanks, Tejinder sir. Thanks, everyone. Thank you. Great. So we'll be sending the update on our next hackathon. So this might come as a relief to maybe people who have joined recently. We would not be having our sessions from 16th or maybe 17th till 20th. So you can definitely try catching up in that particular time frame. Yeah, Vinitsa says, for me, I'm having an idea only, and as I didn't know. Yes, you will catch up soon. Thank you so much, Nada. Okay, great. So looking forward for our upcoming sessions. I would request people who join new and people who are already attending all the hackathons, I'd request you to go through the sessions and go through the actual lectures and understand more of it. A few concepts that were, if they were left out, they were intentionally left out to be covered in our upcoming session where they'll match and make more sense. Yes, thank you, Sujima. Sujima says thanks to everyone. Thank you, Vinit. Great. Okay then. Yeah, thank you so much, everyone. Bye.